So we're now on part 2 of the same question, and now they're asking you to show that the height of the pyramid is 8 centimeters. And first thing though, read, Sylvia's making a square-based pyramid. Each triangle has a base length of 12 centimeters and a height of 10 centimeters. Now once again, on the paper I would draw in what they're telling you, and the tricky important thing for you to realize is the 10 centimeters is the height of the triangle, not the height of the pyramid. And so it's going there. I think our pyramid base, or our triangle base, is 12 centimeters. I'm going to show that the height of the pyramid is 8. So now we look at the height, and there's the height. And basically we can make a right triangle, and that's what we're going to need to solve. So down here, just to show you that we've got this right triangle. I know that the hypotenuse is 10. How did I know that the length is 12? Well, that's because, that the base here is 6. That's because if I just kind of draw that out, that would be the midpoint there. And so from here to here, halfway is 6. And so we now have 2 lengths missing the height. And that's again what we have to show, that the height is 6. And Pythagorean theorem very quickly. So we have h squared plus 6 squared equals 10 squared. That's a plus b equals c. And real quick, we'll just do all of that. That's really how we're going to find h. And so h squared equals 100 minus 36, which happens to be 64. And if h squared equals 64, then we know h equals 8. And that's what it was supposed to be. Okay, now we're ready to answer part B, which is find the angle that MO makes with the base of the pyramid. And so the first thing we need to do is sort of draw where we're talking about. And so I have the line MO, and then the angle it's making with the base of the pyramid. And if you want to think about that, or how I got that, is if from the tip of the angle, or the line, you were to draw a line straight down, where would it land? Or think about, like, I don't know, dropping a piece of string straight down, it would land there. And so that creates where our other side is. And so we can see there's going to be the angle. And so from there, we just need to now look at that right triangle. And so we knew from before that the hypotenuse is 10, the base is 6, and here's the angle we're looking for. And so based on that, I think we're talking about trigonometry, hypotenuse adjacent. That would go with cosine, so we just need to work out that the cosine of angle theta is adjacent over hypotenuse, and that's going to tell you that the inverse of 0.6, I'll do 6 divided by 10 for you, and calculator is going to tell me that's 53.1 degrees. And we're done with part B, and we're ready to do part C. Calculate the volume of the pyramid. Well, the volume of the pyramid is 1/3 because it's a pyramid. Area of the base times height. And so we just have to plug in numbers. That it's 1/3. The area of the base, well, it's 12 by 12. So 12 squared times the height, and the height we found out from part A is 8. And so we just need to say that 144 times 1/3, or 144 divided by 3 is 48. And 48 times 8 is going to be 384. So the volume equals 384, and we're dealing in centimeters, and it's a volume centimeters cubed. So there's one answer for part C, and up here we have part B, and we're almost done. Finally, part D. Daniel wants to make a rectangular prism with the same volume as that of Sylvia's pyramid. The base of his prism will be a square of side 10 centimeters. Calculate the height of the prism. So what we need to know is the volume of Sylvia's pyramid, 384, is to equal his square prism. So let's get rid of Sylvia's work and talk about this one. So we have a square-based prism, 10 by 10, and we're looking for the height. The volume of that is supposed to equal 384. And so really nothing too complicated. It's 10 times 10 times h equals 384. That's 100 h. And divide by 100. H is going to be 3.84 centimeters. Done. Simple as that.